10.5 notes, polar form of complex numbers, page 1. So we're going to start with a review of complex numbers. We have not used them at all this semester. Want to make sure that we are all okay moving forward. So first off, the definition of a complex number. Complex numbers will be written as z equals a plus bi. A and b are both real numbers. I is the imaginary unit. It's the square root of -1. And so sometimes we use that to write things in terms of I. A lot of times we use the fact that I squared equals -1 to put things back in terms of real numbers. So A is called the real part, and sometimes you'll see it as REZ, the real part of Z. That's our A. And then B is called the imaginary part. Now keep in mind, B is a real number. It's just the real number that's attached to the I that makes that the imaginary part of the number. So basic computations, we remember hopefully how to do this, kind of like combining like terms. So if I am adding two complex numbers, I can add the real parts together. So 58 plus 2 is 60. And then I'm going to go ahead and add the imaginary parts together. I've got -1i minus 17i. So that's minus 18i. I'm going to keep the real part and the imaginary part separate. B asks us to multiply these. Okay. We are going to multiply by using the distributive property or the FOIL method. So I've got 6 times 10, which is 60. 6 times 8i, which is 48i, 3i times 10, which is 30i, and 3i times 8i, which is 24i squared. That I times I is I squared. I can combine like terms. I've got a 78i here. My 60's out front. We are reminded here that this I squared is -1. So I've got a plus 24 times -1 makes that minus 24. Now I can combine the real parts. 60 minus 24 is 36. Plus our 78i, we cannot combine those. We are going to do this again. Notice something though, I've got 4 plus 2i times 4 minus 2i. There's a special name for these. These are called complex conjugates. And that just means they look exactly the same except for the signs in front of the imaginary part. One's positive, one's negative. Let's take a look at what happens when we multiply here. 4 times 4 is 16. 4 times minus 2i is minus 8i. 2i times 4 is plus 8i. 2i times -2i, -4i squared. Notice in this situation, our two I terms cancel each other out. I got 16 minus 4 times my I squared is -1, which is 16 plus 4, which gives us a 20. We're going to use that fact, that complex conjugates, in a minute. Notice that when we multiply two complex conjugates, the imaginary part goes away completely. We're left with something completely real. So D, we're subtracting two complex numbers. The reason this is in here is to remind you that this minus applies to both pieces back here. So I have 58 minus 2, which is 56. I have a -I plus 17i, gives me plus 16i. Again, I cannot combine those two parts. I have a real part and an imaginary part. Those need to stay separate. E, dividing. So we don't like having imaginary numbers or complex numbers in the denominator. So we want our denominator to be completely real. And what we're going to do is we're going to take a look at what happened in C, and we're going to multiply by the conjugate. If I multiply a complex number by its conjugate, I'm going to get something that is completely real. So I'm multiplying that denominator by 10 minus 8i. I have to multiply the numerator by 10 minus 8i as well. That's essentially multiplying it by a big giant 1. And so now we're going to go ahead and just multiply. I got 6 times 10, 60 minus 48i plus 30i minus 24i squared. This is over our denominator 100 minus 80i plus 80i minus 64i squared. I get 60 plus 24, so 84, minus 48i plus 30i, so minus 18i, all over our denominator. Let's see, the middle parts cancel out. We got 100 plus 64, so 164. We are not going to leave this. Let's see if I can shrink this down a little bit so I have a little more room. We are not going to leave this way. A complex number has to have a real part and an imaginary part, so I cannot leave it written like this. We're rewriting this as 84 over 64 minus 164 over 164i. That we can reduce. We can divide numerator and denominator by 4 here. We get 21 over 41 minus, these are going to be divided by 2. 9 over what, 82? I. If you prefer to leave them with a common denominator, you're more than welcome to leave it as 42 over 82. You really don't have to reduce at all. That's more out of habit than anything else. Last one, F, same thing. We've got to get rid of the imaginary in the denominator. So we are going to multiply by its conjugate. That gives me 5i plus 35i squared over 1. I know the middle parts are going to cancel out, so I'm going to shorthand it here and write a squared minus b squared. So 1 squared minus 7i squared. In our numerator, we're going to go ahead and flip those around so the real part is first. My denominator becomes 1 plus 49, so that's 50. We've got minus 35 over 50 plus 5i over 50. We can rewrite that as minus 7/10 plus 1/10 I. It doesn't matter if I pull that I out separate or if I leave it in the numerator. Both mean the same thing. Okay, so something new but pretty straightforward. We are now going to graph complex numbers in the complex plane. So we're used to the Cartesian grid with our x being our horizontal axis and our y being our vertical axis. When we talk about plotting complex numbers, our horizontal axis becomes the real axis. And our vertical axis becomes the imaginary axis. Other than that, it pretty much works the way you think it should. If we want the point 1 minus 5i, we're going to go 1 in the positive real direction. So over 1, negative 5 in the imaginary direction. So down 1, 2, 3, 4, 5. Here is our point 1 minus 5i. We shall color code. B, negative 4i, that means the real part is 0. And so we're going to plot it just that same way. 0 left, right, down 4. Sometimes you'll see that vertical axis labeled in terms of I. I don't see that very often, but you might. -2 plus 3i, -2 in the real direction, positive 3i in the imaginary. We're going to highlight that in brown. Don't think I've ever used that color. And the point 3, which basically is 3 plus 0i, so 3 over on the real axis. And then we don't go up or down at all. And there you have points plotted on the complex plane.